Okay, so in geometry we have a lot of definitions we need to go through at the very beginning. And some of the definitions take a long time, so it's great to record them ahead of time. So, section 1-1 deals with nets. It's really fun. It would be great for you to look at, but we have no standards on it, so we don't really cover that. So we go on to 1-2, deals with points, lines, and planes. A point represents a location and has no size. So when we represent a point, we just put a dot and we put a letter next to it. And we'd call that point A. If we talk about a line, line is represented by a straight path that extends in two opposite directions without end and also has no thickness. So if we draw a line, I used a ruler on this one, because it has no end, we put arrows at the end. We also put letters in there. So we put a little dot, that can be A, this one can be B. When we name it and are talking about a line, so if we had several on the page, this specific line is line AB. Or if we look at it the opposite direction, line BA. So we always put the symbol of what it is above it. If we talk about our next definition, this is a plane. Actually, if we look at this piece of paper, we could call that a plane too. A plane is represented by a flat surface that extends without end and has no thickness. So we usually show it as something with sides and ending, like our piece of paper, but it really doesn't. It continues on forever. If there's a letter in it, we can call this plane plane P. Or we have to use at least 3 points. So we could put a point A, point B, and point C on there, and then that would be plane A, B, C. If you see 3 letters together or even 4 letters together, that represents a plane, and we don't need any other symbols with it. If we talk about collinear points, if we look in here, you see the word line as our root word. So we're talking about a line, and the points that we're talking about lie in the same line. So if we have coplanar, the points and lines lie in the same plane. So these points A, B, C are all coplanar. These points A, B were all collinear. So if I have 3 collinear points again, but this time I want to talk about a segment, that's just part of a line. Segment always has 2 endpoints, and it includes all points in between. So if we go from this point A to point B, it would be line segment AB. Or we can go from B to C, and that would be line segment BC. If we go from point C all the way to point A, that's line segment CA. So the letters let us know what part of the line we are talking about. But when we change it to a ray is a point of a line, has one endpoint, and all the points continuing in one direction. So your points start at an endpoint, and that is the first letter you want to use when you write your ray down by a name. So if we start with A and continue on to the right through B and C, we have to write that as a ray. So you show an actual ray, A, and I can call it AB, or I could have called it ray AC. The main point is that the end point is the letter you start with. If I want to go from C to the left through B and A, I have to say I'm at ray CA. We don't change the ray symbol. It still goes from left to right and point to the arrow showing it continues on. It's the letters themselves that show us the direction. If we talk about opposite rays, they're two rays that share the same endpoint of a line. So these rays in here, the opposite rays would be ray BA and the ray BC. Again, BA goes the opposite direction of BC. What lets us know the direction is going from the starting point of B through A, and this one's going from B through C. The symbols on top of them don't change direction. It's the letters that let us know the direction. Okay, so now that we know some of these definitions, we start talking about postulates. A postulate, in some books they call them an axiom. I don't use that term. The postulate is an accepted statement of fact. So, to help you think about that, let's just put 2 points on our piece of paper. And the directions are going to be, draw as many lines as you can through the 2 points. So go ahead. Draw as many lines as you can through those 2 points. Hopefully you're doing it. I can't see you, but let's hope you are. Okay, so now I'm going to draw my line between the 2 points. I can't go over here and draw a line because it doesn't go through the point. I have to go right there and draw my line between the 2 points. Remember, a point has no thickness, so could I have drawn 2 lines through those 2 points? No. There's only one. And because you can only draw one, and you know that has to be true because you just tried it, that's what a postulate is. So postulate 1-1, and they use numbers with it. You don't need to put the number. 1 just means it's from chapter 1 and it's the first postulate in chapter 1. It's easier to just memorize what the postulate says than to remember a number, because when you have to write them later on, I'm not going to look for the number. I look for what it says. So the postulate says through any 2 points there is exactly 1 line. So our next definition is intersection. If you think about the intersection of 2 roads, then you'll be able to find the intersection of 2 lines. So it's a set of points the figures have in common. So if we're looking at 2 lines, how many points do they have in common? Hopefully you just said 1 right there. Let's call that point C. And I'm going to put A, E, since we said it was lines, we're going to make them into lines. And then we're going to put point D and point B on here. So if you look at those 2 lines, they intersect at exactly 1 point, and that's what our next postulate says. Notice I'm abbreviating postulate, P-O-S-T. If 2 distinct lines intersect, then they intersect in exactly one point. And again, I'm abbreviating point, PT. We end up writing so many things in geometry that it's easier if we start abbreviating things. Okay. So if I look at two intersecting planes, we have a vertical plane here and a horizontal plane. If you think of two pieces of paper cutting through each other, this horizontal one goes behind that vertical one. That's why it's dashed. And same with the vertical one goes behind that horizontal one, so it's dashed. And we've intersected two planes. If we look at this intersection right here, we can extend this out, because remember, a plane goes on forever in all directions, even though we just symbolize it ending there. And we get our next postulate. The next postulate says, if two distinct planes intersect, then they intersect in exactly one line. Our next postulate, through any three non-collinear points, there is exactly one plane. If you go back to your picture where we showed what a plane was, I actually showed you, let me pull that one back out, three non-collinear points on that plane. We already knew the postulate, but now we're just defining it, because we could name this plane ABC because there was the 3 points on it. And they're non-collinear because they aren't in a line. So, again, the postulate says through any three non-collinear points, there is exactly one plane. So that ends our notes for today, and I'm going to show you how you find your homework. So when you go into Math Excel for School, and you had your course home, we had our homework, geometry, we looked at all assignments. Oh, that's right, your placement test was in algebra. So we can click on my Geometry Chapter 1, Homework 1. You already did the first 12 questions in here that dealt with the orientation. So we had our numbering in the center, but we also, if we look to the left, had the 0.1.12. This lets us know we were still in the orientation. If we go to the next problem, problem 13, we are at 1.2. That means we're in the second section, and that's where your homework starts. And if you go on down to, so you started at 13, you will answer your questions, keep clicking through until you go to problem 27. Problem 27 says 1.2.31. If we click on the next one, it says 1.3. That's too far, and you want to stop. So always be looking at your numbers here on the left-hand side, and it will help you if you forgot what number you're supposed to stop at the top. Now you may do your homework 1.2.